Now we will talk about the rules for the refraction of light. That means a ray of light traveling from one optical medium to another optical medium, it bends away from its path. The bending of ray of light could be towards the normal or it could be away from the normal. In the previous example, we just considered a ray traveling from one optical medium to another optical medium bends towards the normal. But I have already told you in that section that we will study that later. Here I will just explain you why does a ray travels from one medium to another medium, bends towards normal or it bends away from the normal. I will just give you a mathematical explanation which is not given in our notes or not in our textbook, but I will try to explain it mathematically, and once you can explain that why does it bend towards the normal or away from the normal, the other can be simply understood. So consider a ray of light traveling from optically rarer medium to optically denser medium. So for rarer medium I have taken refractive index mu1, for denser medium I have taken refractive index mu2. Let's take the speed of light in this medium be v1 and here the speed of light be v2. Now we already know that since mu2 is denser, so mu2 का value will be more than mu1 and we can say mu2 upon mu1 will be more than 1. What we also know that since refractive index is mu2 is denser and mu1 is rarer, so speed of light in a rarer medium will be more than the denser medium. We also know that v1 will be greater than v2. One of the reason we say that since the speed of light in a denser medium is less, so it will try to travel a shorter path. To travel a shorter path, the ray bends towards the normal. But I cannot justify this statement, but mathematically I can explain you. If I apply Snell's law, see here, very important. If I say Snell's law, refractive index of 2 with respect to 1 will be sin I by sin r. Am I right? Because ray is traveling from 1 to 2. This mu2 of 1 ka value can be mathematically written as mu2 by mu1. We have already studied in the previous section mu2 by mu1. Now we know that mu2 by mu1 ka value is more than 1. So we can say sin I by sin r ka value will be more than 1. That means sin I will be more than sin r. That means angle of incidence will be more than the angle of refraction. This is mathematically proved because sin, if we can say sin 0 is 0, sin 90 is 1. So as the sin ka angle increases, sin ka value also increases. If I say sin I is more than sin r, then definitely the angle of incidence will be more than angle of refraction. So if this is the incident ray and this is the angle of incidence, right? So can I say by vertically opposite angle this will be I. Now ray of light is traveling from rarer to denser, where we have proved that I will be more than R. So will the refracted ray, means angle of refraction will be less or greater? It will be less. So the angle of refraction has to be like this, because in this case R will be lesser than I. R will be lesser than I. So what we can see that a ray of light traveling from optically rarer to optically denser, the ray has bent towards the normal. This is mathematically justified. And now in this case, if I talk about angle of deviation, this will be the angle of deviation. So numerically, angle of deviation the value will be I minus R. So remember, when a ray of light travels from optically rarer to optically denser medium, it bends towards the normal. Second case, we can take a ray of light traveling from optically denser to optically rarer. So what I am doing, I am taking it as a denser, I am taking it as a rarer. So mathematically mu2 ka value will be less than mu1. So mu2 by mu1 will be less than 1. And v1 ka value will also be less than v2. But Snell's law will remain same, because light is still traveling from medium 1 to medium 2. So mu2 of 1 will be sin I by sin r. mu2 by mu1 will be sin I by sin r. But sin I by sin r ka value is mu2 by mu1, whose value is less than 1. So I will write less than 1. I will write less. So what we have found that when a ray of light travels from optically denser to optically medium, the angle of incidence is found to be lesser than the angle of refraction. So in this example, if I say, if this is denser, this is rarer, this is I, this has to be I. For R to be more than I, the refracted ray should be like this. Now we can say this being the angle of refraction and the ray has bent away from the normal. So remember, when a ray of light travels from optically denser to optically rarer medium, it bends, remember, it bends away from the normal, and we can say this will be the angle of deviation. So this is R, this is our angle of deviation in this case will be R minus I. So we have considered two important rules for the refraction of light. In short, you need to remember, a ray of light traveling from optically rarer to optically denser bends towards the normal. Optically denser to optically rarer bends away from the normal. No one is going to ask you how it is going to be there, how it is bending towards the normal and how it is bending away from the normal. You just need to say rarer to denser towards the normal, denser to rarer away from the normal. Now we have a special case where a ray of light traveling from one medium to another medium, let's say this is medium 1, this is medium 2, be it rarer or denser, it doesn't matter. What if a ray is incident normal to surface? If the ray is incident normal to surface, angle of incidence in this case will be, come on, tell me, 90? No, it will be 0, because angle is always measured with respect to normal. So this being the incident ray, an incident ray is along the normal. You can call it as a normal as well as the direction of incident ray. Now this is a special case where the refracted ray goes undeviated. The refracted ray goes undeviated. So R ka value will also be 0. So the angle of deviation will also be 0. So we have a special case when a ray of light strikes the surface normally. I have to say it goes undeviated. It goes undeviated, that means the refracted ray goes along the normal. So we have a special case where a ray of light traveling from one optical medium to another optical medium goes undeviated. So you have to say, so when the ray of light is incident normal to surface, it goes undeviated. Another reason I will explain you, when does a ray of light traveling from one optical medium to another optical medium goes undeviated. So I will take any medium 1 and 2. Definitely a ray is traveling obliquely. It will move either towards normal or away from the normal. But what I am taking, that refractive index of 1 and refractive index of 2, I am purposely taking both the refractive index as same. That means I have got two different medium having same refractive index. That means the speed of light in both the medium will be same. That means medium ka refractive index same, the speed of light will same. No change in the speed of light, that means no deviation in the path. So remember, a ray of light traveling from one optical medium to another optical medium obliquely may go undeviated. It may go undeviated provided the refractive index of both the medium remains same. So under two conditions, a ray of light will never bend away from its path. First, if it is incident normal to surface. Second, the refractive index of both the medium is same. So this is a special case you need to remember. A ray of light traveling from one optical medium to another optical medium goes undeviated under two conditions: if it is incident normal to surface or if the refractive index of both the medium is same. Thank you.